regressions, problem number 1. The percentage of students scoring 85 or better on a mathematics final exam and an English final exam during a recent school year for 7 schools is shown in the table below. So we have 7 schools, percentage of students scoring 85 or better, and each row is a school, right? With their percentage of that scored 85 or better, as it says. So what we want is menu, new, add list. We can name these mathematics or X. I'm going to do X, keep it simple. English or Y to keep track. So one's on X-axis, one is Y. So, and then we want to enter a day, 27, 12. Okay, after, you want to make sure that you have accurate numbers now here. If you have inaccurate numbers, you're going to get inaccurate results. Okay, so the goal is to write the linear regression equation for these data, rounding all values to the nearest hundredth. All right, so what we want to do here from here is control doc, add data and statistics page. Click here. This is going to be Y, X. So now it's plotted. That's scatter plot. This one says 1345. Right here, that's this. Right here, 1345 for that school. And now we want to solve this. So menu, analyze, 4, 6 regression, show linear. So this is y equals mx plus b form, which is what we want. And bam, it gives us an equation for our regression equation. So the goal of this line is to be the closest it can be to all these points together. All right, so this says right here, the equation. So we want to write this down, right? Y equals, it says 100, this is 10th, hundredths, round up. So 7 rounds up to 0.96. And then over here, we want to round up to hundredths, so tenths, hundredths, so 23.95. And of course, it equals Y. So we've solved this. And now we want to state the correlation coefficient of the linear regression equation to the nearest hundredth. So for that, we want to go back to our original page, 1.1. Go over here to the D1. Now we want, and then we want menu for 1. This one, as we've seen earlier, right? Linear regression. We're doing regressions. This is in y equals mx plus b form. Push it. Okay, our first list. Make x list x, y list y. This other stuff can be okay right now. And there we have it. We have, so there's linear regression. This is the form it's in. And now we have M, notice our M right here, B right here, and we want the correlation coefficient, which is R. So it's 0.92, rounded to 0.92. So what does this mean? Well, correlation coefficient of 0.92 indicates a very strong positive linear relationship between two variables, meaning that as one variable increases, the other tends to increase as well. This high value suggests that the data points closely follow a straight line, as we could see on our, right, pretty close to this line. So positive, right, because it's a positive number. The closer to 1, the stronger, the closest the line are to the dots. Closer to 0, the more scattered these dots are going to be in front of this line. And it can go negative. So if it's negative, right, it means negative correlation, which means this slope would be negative, right? It would be going down. Thank you. So it can go up to, well, down to -1. So -1 R value would be these dots would be on the line basically. Closer to 0, farther away.